Hi everyone. In this video we're going to be working on 2015 AP Calculus AB Free Response question number 5. Now, when you see this question, before we get started, I want to explain a couple things. Every time you see this question, you're going to see a graph. And chances are, when you notice this graph, it's going to be F prime. Sometimes you're going to have to work for it, but the graph that's given is F prime. Now, the fact that it's F prime, you're going to be setting up things like number lines, which we'll go over in example B and C and A. But also, I want you guys to notice that you're going to understand that in order for your success in this exam, everything below the x-axis, because this is F prime, is a slope of negative, meaning that these are your negative slopes, meaning it's decreasing. All the stuff down here. Anything above the x-axis means it's increasing. Why? Because this is F prime. F prime stands for slope. Okay? So anything above is positive slope, meaning therefore it's increasing. Anything below is be negative. So let's go ahead and get started. It says the figure above shows a graph of F prime, the derivative of a twice differential function F. Twice differential function F just means that I could derive this twice. They already derived it once. We're probably going to do it once more. It says on the interval -3 to 4. So those are my bounds. The graph of F prime has a horizontal tangent line at x equals -1, x equals 1, as well as x equals 3. What this means is if I were to find a derivative, I'm going to get a slope of 0 here. So it's a resting point. It says the areas of regions bounded by the x-axis in the graph of F prime on the intervals -2, 1, and 1, 4 are 9 and 12 respectively. The word respectively means in that order. So because -2 and 1 comes first, 9 goes with that one, 1, 4 second, 12 goes with that one. So since they're telling you those are the areas, well, between -2 to 1, this is going to be 9. Except one thing, the fact that it's below the x-axis, remember, it's a negative area. And 1 to 4, 12, also below, therefore negative. So let's go ahead and get started. It says, find all x coordinates at which f has a relative maximum. And I'm going to go, okay, relative maximum, how do I find that in calculus? Relative maximum is finding the first derivative and setting equal to 0. I find the first derivative and set equal to 0 so that I can find critical numbers. Well, if I'm setting the derivative equal to 0, isn't this the derivative f prime? And where does it equal 0? At my critical numbers. So whenever they ask you for a max or min or increasing, decreasing, you need to understand that in your derivative, your critical numbers are your x-intercepts. So pretty much -2, 1, and I don't really have to say 4 because there's nothing right of 4. So for part A, I'm gonna have you set up a number line every single time. And in my number line for f prime, I'm gonna have you put the critical numbers, which are the x-intercepts, -2, 1. And then I want you to kind of separate the graphs. Now remember when we said everything above the x-axis is increasing, therefore left of -2, it's increasing because it's above the x-axis. The -2 all the way to 1, everything's below, hence the reason why you have a negative area, that means it's decreasing. And then from 1 to 4, also below, decreasing. Now what I want you guys to notice is this, when you set up your number 9, ask yourself, is there a max? And there is, because from -2 to, it's going to turn. There's a change of signs. So there's a max at -2. And that's the question. That's what they wanted you to find. Find all x coordinates in which f has a relative max. And you're going to say that your max is at, so your max is at x equals -2. And they're going to ask you, give a reason for your answer. Because f prime of x changes from positive slope to negative slope. And that's your reason. Okay? So that's your answer for part A. What you need to do though, in order to be successful in this question, is you have to set up a number line so that you can differentiate between positive slopes, which are above the x-axis, and negative slopes, which are below. Your critical numbers are when f prime of x equals 0. Those are your x-intercepts. Okay, so let's go ahead and do part B. Part B says, on what open intervals contained -3 to 4 is the graph of f both concave down and increasing or decreasing? Well, the good thing is we just solved for decreasing. So in your work, you have this. and this is from the step above. F prime of graph, your critical numbers were at -2, 1, and you said it was increasing, decreasing, decreasing. So now they're asking you, okay, well, we already know where it's decreasing. Well, that's not to figure out where it's concave down. Well, concave down is going to require you to do a second derivative. And then you're going to go, okay, well, if I have my first derivative, how do I apply a derivative to a graph? You need to memorize this. Whenever you apply a derivative to a graph, you're applying pretty much, you're determining the slopes at every single point. Positive slope meaning increasing, negative slope meaning decreasing, and resting points. That's why they told you this horizontal tangent line to x equals -1, 1, and 3. Because these are going to be your resting points. So, once again, whenever they ask you to find a derivative of f prime, look for the points where they change direction. For example, -1, it goes from decreasing to increasing. That's your first point. And I'm also going to put that between -2 and 1. Your next point is at 1, changes from increasing to decreasing. And that's the, oh actually no, I'm lying. One more, 3. So once again, when I'm finding my second derivative, I'm going to set up this number line. And the numbers I'm going to put here are the points where it changes direction. Max and mins every single time. Max and mins of your first derivative graph whenever you have a graph. And then your next thing is, okay, well, left of -1, it's decreasing. Well, yeah, it's awesome. It's decreasing, but for second derivative, decreasing means concave down. From -1 to 1, it's increasing. That's awesome for first derivative, but for second derivative, that means it's concave up. And then lastly, 1 to 3 would be concave down. And then 3 to 4, it's increasing, so concave up. So the question says, when is it concave down and decreasing? Well, the one thing you're going to notice first is this. It's concave down here, and it's concave down all the way to -1. Well, you notice from -2 to 1, it's decreasing as well. So your first interval is going to be -2, because that's where it starts decreasing, and ends at -1. Then your next interval is going to be concave down here, decreasing there. That's perfect. 1 to 3, and I stopped at 3 because after 3 it starts to concave up. Now the reason why I always want you guys to set this up as first derivative and second derivative on top of each other is so that you can kind of have a better visual of where it's actually decreasing and concave down. This is a question they typically put on there. But without setting up this number line, it becomes very difficult. Okay? So remember, the reason why I found these numbers as critical numbers on my second derivative is because that's where the change occurred, the max and mins, the resting points. Alright? So, moving on to part C. And by the way, for part B, when it says given the reason, you can just say the same thing. It changes direction from at every single point. Okay, so moving on to part C. Part C says find the x coordinates of all points of inflection on graph F. The good thing is, for part C, so let me separate this. This is my second derivative. So ask yourself, how do I find points of inflection? Well, remember, points of inflection are when they change concavity. Well, when do they change concavity? When it goes from concave up to concave down. Once again, points of inflection are when it changes in concavity. So without this, I wouldn't have been able to figure it out. Well, it changes in concavity at -1. You see how it goes from concave down to concave up? So then your first point would be x equals to -1. Your second point goes from up to down 1, and your last one goes from down to up, so it would be 3. So the 3 points of inflection that you would have would be at -1, 1, and 3. How do I know this? Because it changes from concavity at every single point. Okay, so when it says give a reason, just express it changes direction or it changes concavity at every single point. Okay, moving on to part D. So far, out of the first 3, A, B, and C, we've been working on 6 points. So there's a final 3 points in part D. Now part D says, given that f prime of 1 is equal to 3. So when I see that, why else are they giving me? That's my initial. I want you to actually write initial so that you understand you're going to be using this. This value is going to help you figure out possibly another value later on. It says write an expression for f of x that involves an integral. And then it says find f of 4. Well, remember, the fact that they told me that f of 1 equals 3 I can find any value I want or any position I want, because what you need is you need an area. So when it tells you to create an expression, well, remember the time, whenever they give you an initial, write this. F of 1, your initial, plus your initial to any point they want. X of what? Well, with the graph that's given to you. F prime of t dt. That's your integral. And this is actually final position formula. Anytime they ask you for a position, it's your initial plus your starting point to whatever point they want, forwards or backwards of the equation that's given to you already. So then the second part says, find f of 4. Okay, well that means I'm going to take 4 and I'm going to plug into x. So f of 1 plus 1 to 4 of f prime of t. And a lot of you are probably wondering, well, how am I going to find this antiderivative? Remember, antiderivative, another word for that, means area. Well, anytime you're given a graph, you're just going to find the area from 1 to 4. Well, if you think about it, 1 to 4, they told us had an area of negative 12. So this is going to turn into negative 12, and then f of 1, they told you was your initial, which your initial was 3. So this is going to be 3 minus 12, which equals negative 9. And that's going to be your position at 4. Your value at 4. Your initial, your starting point, plus the area that you're traveling from 1 all the way to 4. Okay. Moving on to the last one, f of negative 2. Well, f of negative 2 is the same thing. Your initial plus, where am I starting from? I'm starting from 1 all the way to negative 2 f prime of t. Now, another thing that's confusing is the fact that your bounds are different. It's lower. 1 isn't really lower than negative 2. It should be the opposite way. So what you do is just flip it. And when you flip it, you're going to actually take a negative on the outside. And then put negative 2 to 1 of f prime of t dt. And then f of 1, once again, is 3. That's our initial. And then minus, what is the area from negative 2 to 1? Negative 2 to 1, they told you was negative 9. Once again, the area from negative 2 to 1, integral means area, is negative 9. This is going to end up giving you a value of 12, and that's your answer. Okay, and that would wrap up the 9 out of 9 points. So any question that you ever see with this, remember, if you see a derivative, set up a number line. The number line is going to help you figure out increasing, decreasing, points of inflection, concavity, max, mins. And if they happen to give you an initial point, use this initial point to help you find another point by setting up an integral. Initial plus your starting point, your initial, to whatever value they want, forwards or backwards. We had an example of both. Okay? So I wish you guys a lot of luck. Let me know how it goes. Thank you for watching.